In this part 2 of the Quick Install and Setup video series, we'll be installing and setting up the SoftHub platform and its components. First, we'll install the files on the Raspberry Pi needed to run the SoftHub daemon. Then we'll install the SoftHub configuration utility on our Windows computer. And lastly, we'll set up the optional remote packet capture service on an AWS cloud server. Note this third step is only required if you intend to use the SoftHub's native remote packet transport capabilities. So let's get started. First, we'll go to the support page of the OmnIoT website and download the current generally available version of the platform. We'll extract the file's contents, and we see 4 subdirectories. One for the SoftHub configuration utility, one for the SoftHub documentation, one for the SoftHub packet capture service, and lastly, one for the Raspberry Pi SoftHub installation package. In the root directory, we also see a release notes file as well as the installation overview README. In the Raspberry Pi subdirectory, we find 2 files, the installation notes as well as the install package tar file. We'll log on to the Raspberry Pi we configured in the previous video and then use the pscp command to copy our tar file to the Raspberry Pi. Before we proceed, looking at our installation prerequisites, we see we need to install the PIGPIO package. Once that's complete, we'll extract the SoftHub tar file per the installation instructions and then cd into the installation directory. Here we simply run the installation script, which in turn makes the modifications to your system necessary to install and enable the SoftHub daemon. We'll go back to our laptop and now install the SoftHub configuration utility. Next, we'll create our installation directory. Since the configuration utility is a simple exe that doesn't write any files other than the rule engine files it creates, we can simply copy the new exe over any old exe. We'd previously created a shortcut on our desktop, so that shortcut will now point to our updated exe. For the final step in our installation guide video, we've configured a remote AWS server where we'll install the remote packet capture service. We'll first open a remote desktop session to it. Again, as mentioned at the start of this video, this is an optional step and only required if you want to use the SoftHub's native remote packet transport capabilities. We're going to use it as part of our verification process in the Part 3 video though, so we'll go ahead and install it per the installation instructions. First, we'll copy over all our files into the installation directory specified in the installation notes. And then we'll go through the few remaining steps in the installation guide. Specifically, we need to register the service in the system using the sc command. We also need to edit the Packet Capture Services configuration file to specify the port we'll use to receive packets through. We'll use port 27554. The next step is to open the port on your system to allow remote connections. If you are using a cloud server, this process varies greatly by vendor. We've already enabled port 27554 on our AWS control panel system previously, as well as on our server, so there's nothing to do here. In the installation guide, the next step is to create and distribute your encryption keys. The SoftHub's native packet transport facilities establishes connections using full TLS encryption. For our example, though, this is not really a concern, so we'll just use the default OmnIoT keys and certs sent with the installation package. In a normal installation, if you are communicating over the WAN, you would definitely want to provide your own keys and certs as documented in the installation README. And that completes our installation video. Again, we've glossed over quite a bit for the sake of expediency, so please refer to the installation documents for more in-depth information as needed. Tune in for our third and final video in the series where we'll actually create and execute an example rule set. The rule set will connect to a sensor and forward each packet received to both the public Mosquito MQTT broker as well as our AWS-hosted remote packet capture server. Thanks for watching.